Alright, in the previous video I was trying to draw in here and I realized I don't have my draw up here. So I want to show you how to do that. If I just go to the ribbon, and for me I right click on it here and say customize the ribbon. Go over here and I want to just add the draw tool. We're going to have some things where we want to draw and it's kind of useful, but it's also good if you want to annotate stuff. So now for this one I was kind of hoping to draw. There we go. Let's just see here. See if it'll let me here. Oh yeah, if I draw on this picture, so we have this side length is 8, and then if we take that 8 and cut it into 2, we get the radius of 4. And I kind of did the work there already, but I just want you to have that as a tool. Now you have to click off of it and get out of there, or it can mess stuff up. So I want to grab a couple more questions and show you how I might use Excel to solve these. Your financial planning company has a large database of clients. There is a 0.59 probability the client has a 401k. There is a 0.283 probability a client has a Roth IRA. There is a 0.823 probability the client has a 401k or a Roth IRA. What is the probability that a client has both a 401k and a Roth IRA? So I'm going to just snip this. And I do that by using the little Windows button, Shift and S, and then I'll pop over here to Excel. I've got a new sheet. I'll call this question 8, and I'll just paste it over here. And that's not too bad. Zoom in a little bit so maybe you can see better. But really, we're just going to take the information we have here and put it in some form that we can use. So there's a 0.594 probability the client has a 401k. So I'm going to say that's probability of A. Event A is a 401k, and 0.594. Now I could use some words there, and sometimes I do. The Roth IRA, probability of B, is 0.283. And that's just taking these from the reading. There's a 0.823 that probability that the client has both, not both, a Roth, a 401k or, so that's A or B, and that's 0.823. And we are interested in finding those who have both. So probability of A and B. Now, I had some formulas here earlier, and I made them go away. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. And maybe I can draw that. I'm not sure. The probability of A or B is the probability of A plus the probability of B. Okay. Minus the probability of A and B. So there we have that. Now we're looking for this one. So if I add it over to this side and then subtract this one, my algebra, A and B, and then I'd have probability of A plus the probability of B minus the probability of A or B. Right? We add this one, we subtract this one, just kind of switch their places. So, grab my cursor here. So the probability of A and B, if I just take here, I've got A plus B minus A or B. There. You can think of it with the numbers there too. But again, just trying to use Excel to do some of the work for us. So 0.54, 0.54. Hopefully it shakes out okay. Oh, phew. Always nice when they work. This problem, every cereal box has a gift inside, but you cannot tell from the outside what the gift is. The store manager assures you that 22 of the 51 boxes on the shelf have a secret decoder ring. The other 29 boxes on the shelf have a different gift inside. If you randomly select 2 boxes of cereal from the shelf to purchase, what is the probability that both of them have the secret decoder ring? So again, grab this, head over to Excel. Question 9. paste, a little zoom. Okay, so you might want to start using some probability rules, but we just have like the probability of one thing happening and another. And so if I want both of these, the probability that the first one, so let's say event A here is the probability that the first one has a decoder ring. Well, 22 of the 51 boxes have the decoder ring. So I can say equals 22 over 51. And if I want to show some work here, it looks a bit like this. So this is the first one having a decoder ring. Now, the probability of the second one having a decoder ring, B, and I'm going to use given here, A, which I don't necessarily have to consider this way, but I just kind of want to explain it this way. So now B is the probability that the second one has a decoder ring. Now, if we had 22 decoder rings and we got one, we have 21 decoder rings. If there were 51 boxes and we pulled one, we've got 50 boxes. So the probability of B given A, we have to adjust these numbers down a little bit because we've taken one of the successes and we've taken one of the boxes. So then the probability of A and B will be these guys multiplied together. And one thing I'm doing here is I'm just letting Excel do all the work. I'm going to round the final answer. It says to 3 decimal places. So 0.181 would be my final answer here. If I want to highlight it. And 0.181 or 181 thousandths. No. Anyway, you don't necessarily have to write probability of B given A, but it's just a way to do that. Sometimes with these ones, it's kind of fun to just consider what we have. I'm going to skip over this one. Ooh, this one gets a little crazy. Hopefully I have time for it here. Pollsters are concerned about declining levels of cooperation among persons contacted in surveys. A pollster contacted 99 people in the 18 to 21 age bracket and finds that 84 of them respond and 15 refuse to respond. When 253 people in the 22 to 29 age bracket are contacted, 231 respond and 22 refuse to respond. Assume that one of the 352 people is randomly selected. Find the probability of getting someone in the 18 to 21 age bracket or someone who agreed to respond. So I'm going to take a snip of this and show you how I might organize this using Excel. So we are on to question 11. This here, I think that's readable. Okay, so we've got pollsters here. There are 99 people in the age 18 to 21 bracket, so I'm going to say 18 to 21. This is the age, and we've got 99 total. 84 of them respond, so respond. And 15 refuse. Easy for me to type there. And then in the 22 to 29, we have 253 people, 231 respond, and 22 refuse. Now we don't always get all of this information. Sometimes we have to fill out the total here, and it's a good idea here to just double check. Yep, that adds up. That adds up. And then if I add these, I get to the 352. So we have that. Now, find the probability of getting someone in the 18 to 21 age bracket. So all of these are successes, and that total here is right here. So this is a success, and we don't need to count these because we already have them. Or someone who agreed to respond. Well, we already have these 84 that agreed to respond, so we need to add these ones who agreed to respond. So these are our successes. So the probability then of A or B, the successes is the sum of this, that's all of the 18 to 21, and then we add the people that agree to respond out of the other one. We don't add these ones again. We don't want to double count them. So these are the successes. So our probability then is 330 divided by, and we were given that 352, so I'm going to just type it in there. And if we round this to 4 decimal places, notice I've got 4 decimal places only, so I might want to go out here and see. Okay, it looks like that it must stop at 4 decimal places. So 9375, 0.9375, and we'll see how we did. Okay, got it. Sorry, that ran just a bit longer than I intended. Please let me know if you have any questions. Thanks for watching.